MSHD。OK 好，咁可以大家過去 say 個 hi 先。我 Google Meet 呢邊我就會 mute 聲啦。Oh, testing. Sound okay? Is the sound okay in YouTube here?
Sound is.
So when you have arrived here, please say a hi in the chat room. And today we will then go on to asymptotes of yesterday, example of yesterday, and some more. Sound okay? Oh, thank you, Kinson. Thank you, Henry. Also say a hi if you have arrived here. Okay, and then I change back to my iPad display. 有冇㗎？哦 ，OK。Okay, so I changed to my iPad display here. So this was yesterday's notes, but then after the lesson I tried to make different colors for different kinds. Yesterday we were talking about different kinds of asymptotes. The vertical one, we can always do it by I zoom it in and see clearly. So the example, maybe we don't need it right now. So there are three kinds of asymptotes, and then so one of it is the vertical asymptote. That the curve will get nearer and nearer to a vertical line, and then if we want to find vertical asymptote, then we can set the denominator of the function to 0, and then find which x. Then that x will correspond to the vertical asymptote position. Okay, and so this is a case for vertical asymptote. Okay, yesterday we talked about horizontal asymptote as well. And then so horizontal asymptote means that when the curve goes very far away, like go to positive infinity, when x goes to positive infinity, or when x goes to the other side, negative infinity, then it will go nearer and nearer to a horizontal line. Then it is a horizontal asymptote. And then one way to do it is we try to take x tends to infinity and see if y is a constant. Yesterday we took a simple example to show it is a power 1 over power 1 function, and then we try to take the limit for x tends to infinity, and after working out the limit we find it's a constant, a fixed number 4 over 3, and then therefore this function, as x goes to infinity, it will go nearer and nearer to 4 over 3. Therefore the horizontal asymptote is y equal to 4 over 3. And then yesterday we also showed with the Geogebra graph, and today maybe I will also show you some Geogebra graph to understand the situation. Okay, so lastly we also talk about oblique asymptote. Oblique simply means it is not vertical nor horizontal. That means it is not the above two cases. Then the oblique asymptote. Okay, so when oblique asymptote, then it means the graph will go nearer and nearer to an oblique line. That means it is not horizontal, not vertical line. And then the way to work out an oblique asymptote is that we can do long division. And if the quotient is degree 1, then the oblique asymptote will be simply y equal to the quotient. We had this example yesterday from the textbook, but this is not in your textbook. It is in my textbook. That an extra example in my textbook to find the asymptote of a little bit complicated example. That we try to expand the numerator denominator and see the result, and then we do a long division, and then and then we try to rewrite this whole thing, and then in using the long division result, that is the division algorithm, then we find that the quotient will be cancelled. The term with quotient, we will have some cancelling, and then the quotient will remains. And then while here it will be the remainder and the outside the divisor. And then as x goes to infinity, since the remainder is a smaller degree, then of course this whole thing will go to 0. And then so that the function will be getting nearer and nearer to the quotient. The function will be getting nearer and nearer to the quotient. And therefore, this x minus 2, or to be in full, y equal to x minus 2 is the asymptote of the function. And also it is not a vertical line, not a horizontal line, therefore it is an oblique asymptote. Also, this is a little longer example. Maybe today, shortly afterwards, we will also show an example. We will also do an example together. Also, like this one, we will need to do long division. But then yesterday, I promised to show you the graph of this function and see how this asymptote may look like. Okay, so here you can see this is x minus 2 is the asymptote. That is the division, the quotient of the division. And then after we do the division, this is the quotient. And then so this is the asymptote x minus 2, or the full equation will be y equal to x minus 2. So let's see the graph then, how would it be like. I'll change to the Geogebra display here. So Geogebra display, turn this off and then, turn this off and then turn this on. Okay, so this is the Geogebra display. I have already plotted the graph here, and so I try to move the function here. Okay, so the orange one is the function. So I turn off on. Okay, so and you can see the shape of the graph is like this. It's like going from very down and then up to very high, and then after this, then it goes down from the very high position, and then there is a turning point here and going up again. Okay, so one observation here would be because the denominator is 2x plus 1 whole squared. That means when the denominator is 0, we have vertical asymptote. That's the first case. Okay, so when the denominator is 0, we have a vertical asymptote. And when denominator is 0, then easily we can know x is negative 1 over 2. Negative 1 over 2. And therefore the negative 1 over 2, it is the vertical asymptote. So I also put it here to show you this. X equal to negative 1 over 2. So this is the blue line here, shows the vertical asymptote. And then so if I zoom out the graph up more, then you can see how the vertical asymptote be like. Alright, so the blue line here, the blue line is not the x-axis. The x-axis is a little bit next to it. But then the blue line is the vertical asymptote. It is when the graph denominator is 0. Okay, what about the oblique asymptote of this graph? Then from calculation, we did that it was y equal to x minus 2. And then we also see how this asymptote may be like. So I plot in red the y equal to x minus 2. Then you can see from the Geogebra here that how the asymptote may be like. So pay attention to the orange graph and also the red straight line, the so-called asymptote. And then so you can see, if I zoom it in, then you can see the orange line gets nearer and nearer to the red line. And that is exactly the idea of asymptote. And you can see the graph goes nearer and nearer to the red line in both sides. Both the left-hand side and the right-hand side is going nearer and nearer to the red line. Also in the right-hand side, that means the positive infinity case. So you can see the orange line goes nearer and nearer to the red line. So this is the case for asymptote, and it is how we see it from the graph. While on the other hand, if we would like to know how to calculate it or how to do some calculation work on it, then we refer to the textbook and the notebook example again. Okay, so we refer to here. We do long division and then to rewrite the result. Or generally, I can maybe put it as in the notebook to give an easier way, because you can see here in fact we are writing quite a lot, splitting the fraction and then do cancelling and then to have the result. To make it as a mechanical way that we can do, to find oblique asymptote, I turn to a new page and show something. To find the oblique asymptote, I still keep to use the purple color. So to find oblique asymptote, we can use the following way. Is that so if the function is px over qx, then we do long division. Again, same as before, we do long division. And then from the long division, of course, we will just do as usual, put the px inside and the qx outside. And then here, okay, qx. Anyway, small letter and capital letter, we can distinguish it. Okay, so and then when we do a long division, there will be a quotient, big Q, capital letter Q here. There will be a big Q as a quotient, and while there will be a remainder finally. And then we can rewrite this original function. The original function can then be rewritten to quotient x plus a remainder x over the divisor x. So you can take this as a easy way to help you find oblique asymptote. That is when you have a function, or more specifically, this is called a rational function, polynomial over polynomial. Then we do long division. And after the long division steps, then we will have the quotient and the remainder. The quotient will be as like outside, while the remainder will be put on top, and the divisor still same here. So in fact, it is not something very new, because do you remember in primary school? Do you remember something like this? Do you know what I'm going to talk about? In primary school, you also did something like this. Because like if you are doing 14 divided by 3, then you will have, it is 4 and then 12 and then 2. Then you will make this into 4 and 2 over 3. It's exactly the same idea here. They are exactly the same idea. The quotient is put outside. The quotient is put outside, while remainder is put on top. Remainder is put on top. And then finally, the divisor put at the bottom. Divisor put at the bottom. Therefore, it is in fact nothing very new. It is exactly the same as what you did in primary school when you make the mixed fraction. Alright, so then you can consider this as a very quick way. Now then, okay, for an oblique asymptote, then if this degree of qx is equal to 1, then the oblique asymptote will be y equal to qx. Okay, so this is a general way for us to find oblique asymptote. And later we will see more example how this can be found. I got some signal questions saying 如果 long division 唔小心做錯，全題仲有冇分？It is a very important thing. If you do long division wrong, of course then everything following will be wrong. That is, for example, if you do the long division carelessly and you get the quotient or the remainder wrong, then of course this quotient or remainder will be wrong. And then everything that follows will also be wrong. Therefore, be very careful. And also especially be careful when you do long division. That's a good question. Okay, be careful when you do long division. So did I answer your question? Long division. Also, Henry asked, long division 好似好煩. Okay, long division seems troublesome. Not really, because you can see in our M2 syllabus, the polynomial over polynomial thing is not really so difficult. Usually, I think the most I see is power 3 over power 2. Then you can still do the division quite easily. Usually it will not be power 4. Or even if it is power 4, still it is not really so difficult. Alright, yesterday we also put that what about if the quotient is not degree 1? If the degree of quotient is not 1, then we also put notes here to give a supplementary. Okay, maybe I make this whole thing smaller so I can have more spaces. Oh, okay. Okay, so if the degree of qx is 1, then the oblique asymptote is already the y equal to qx. Now what about if the degree of qx is bigger than 1? If the degree is bigger than 1, that means this quotient is like, for example, quadratic power 2, or maybe even higher, power 3, power 4, then that means this original function will be going nearer and nearer to this qx. Because this rx is a smaller degree, the degree is smaller than this one. Therefore, when you take x tends to infinity, this will surely goes to 0. Okay, this will surely goes to 0. Therefore, the function will be going nearer, and so if qx is not just power 1, it's higher. For example, it's power 2, power 3. Oh no, seems okay, getting better. Seems there is a little bit lag here. But it has resumed. It's better now. Okay. It's better now, right? Is it okay now? Is it okay now? Is it okay now? Yes. Okay, it's okay. Now, so if this is not just power 1, for example, it's higher power 2 or 3 or 4, then it means this function is getting nearer and nearer to a power 2 or 3 or 4 polynomial. That means it is not there is no asymptote. We cannot find just a straight line because it is going nearer and nearer to, like, for example, a parabola, but not a straight line. And therefore, if the degree of qx here, the quotient is bigger than 1, then no oblique asymptote. And finally, if the quotient degree is smaller than 1, and then if it is smaller than 1, that means it is equal to 0. Then, in fact, if the degree of if the quotient is degree 0, then in fact we still have some asymptote, but in this case it is not oblique. Then in fact the asymptote is horizontal. And the reason that the asymptote is horizontal is because it is the function is getting nearer and nearer to qx, but qx is degree 0, means it is just a constant. It's just a number. Therefore, the function is getting nearer and nearer to a number, and then the number will then be a horizontal asymptote. So the asymptote is horizontal, and it is the y equal to qx, still qx. Although it is when it is degree 0, then in fact it is not a usual function. It's just a number, and it is just a number. Then it will be y equal to that number. Also, this is a whole case for oblique asymptote. We can do something like that also by referring to earlier example, especially about the degree 0 thing. I try to take a previous example for horizontal asymptote to show how this will also work when we do long division. Okay, so I also try to show you this. I try to do this example again, but not taking limits. Before we try to take limits, and then we find the answer. But then now this time I try to do it in another way by long division. The same example. But then I try to do long division. So we try to do long division. And then so if we are to do long division, then it will be 4x minus 3, and then divided by 3x plus 2. Okay? And then we try to make the first one match to the first one. And then 3, how do we make it into 4? Then we can multiply by 4 over 3. And by multiplying with 4 over 3, then we have a 4x, and then plus 8 over 3. The fraction is a little bit complicated, but still they're just numbers. And then do a subtraction. Then negative 3 minus 8 over 3, and therefore it is negative 17 over 3. And this is indeed the result. After the result, because we can no longer make negative 17 over 3 from this, and therefore this is the result. And therefore the original function 4x minus 3 over 3x plus 2 can be rewritten to 4 over 3, and then plus negative 17 over 3 over 3x plus 2。呢個係同小學嗰個做法一樣啊，又係將個 quotient 放前面，然後 remainder 放上面。OK， 就同小學嗰個一樣嘅，或者學同上一版嗰個教你嗰個快方法一樣。Okay, and then so we have rewritten it. And then next, so then the quotient will then be the asymptote. Because the other part, the fraction part here will always goes to 0. Therefore, from here we can see the asymptote. But in this case, you can see this is just a number, not power 1, not linear. Therefore, it is not an oblique asymptote. So I just say asymptote. So the asymptote is y equal to 4 over 3. Still, just copy the quotient here. Okay, so this is how we do this same question. And then we don't need to do any taking limits here. We just do a long division, find the quotient, and then we have it. So far, any questions? I try to elaborate more with the example for last time. In fact, nothing very new, but then I try to elaborate and try to summarize everything we have for finding asymptotes. So any questions for here? Try to say it if there are any question, and or you can say okay and let me know. Okay. We can go back to the summary part. 咁其實咧呢個咧我可以將佢轉埋色啦 ，horizontal 都好 ，horizontal 都好咧，其實你都可以用紫色嘅方法嚟做噶，係咪應該唔使後面嗰個唔轉啦 ？horizontal 咧你都可以用紫色嘅方法嚟做噶。我轉翻 colour 啦，咁我轉翻隻紫色一樣噶，其實即係你唔需要 take limit 就唔需要，即係話呢個其實係可以唔需要啊，可以唔需要啊。You can still do the same thing with long division. Because long division, the quotient also give you the asymptote, no matter it is oblique or horizontal. Therefore, I usually like to summarize these two and call it non-vertical asymptote. I usually like to summarize these two and call it non-vertical asymptotes. Okay, then now so I see a few OKs here, and then so we go back to the textbook and do something, do the classwork. Let's take some time and do some classwork here. I see we have about like 8 minutes. So let's do classwork 15. Classwork 15, and find the asymptotes. We have answers here already. You also have your answers in your own textbook. But then try to get these answers from suitable ways. So find the oblique asymptotes for each of the following graphs A and B. Now let's take like 2 to 3 minutes and do it, and then we check the answer when it is 3:10. Okay, so let's do this one. So to find oblique asymptote, we can always do long division. And also it is a time to test whether you are careful for long division.做 long division 嗰時，留意要留翻啲位啊！ Okay, so you check the your work against the work on the screen and see is it okay. So is it okay? Okay, so I feel okay here. So I see time is almost up. Maybe we don't start something new, but instead we go to the worksheet. Probably you have not printed this out, but anyway you can still mark down something in the notebook, and we try to do something like the exam, like what exam would be asking for us. Also, I will turn to the curve sketching worksheet that I sent just send you just before this lesson. Okay, we can see some examples here. So it is a really DSE question, the XK DSE 2012 DSE question. So you are given a function, and then you want to find the minimum points and the asymptotes of the graph. Okay, so minimum point and asymptote. Okay, now I also hope to use this example to show you more, but probably we may not have the very enough time because just 2 minutes left. But then so I want to show you this example that in fact the step of finding asymptote could be even useful for minimum points. Now therefore we take remaining time and do the asymptote part first, and then we go on tomorrow and see how this can also be helpful for this. Alright, so we do this first, the asymptote, and same as before, we will do a long division, x squared plus x plus 1, and then divided by x plus 1, and then make it, and then so x squared plus x, and then subtract, then nothing else, nothing remains, and then it's just 1 left behind, and therefore the y can be rewritten as x plus 1 over x plus 1, and therefore the oblique asymptote, sorry, wrong spelling, the oblique asymptote is sorry, not equal, is y equal to x, is just the quotient, the outside. So this is the oblique asymptote, y equal to x. By the way, any more asymptotes? Because there is a bracket for asymptotes. Is there any more asymptotes that we can find from the graph? So the oblique asymptotes we can find here is y equal to x, which is the outside. Any more asymptotes we can find here? There are 3 kinds of asymptotes. We have found the oblique one by long division. Anything else? Yes, there are also vertical asymptote, right? So y equal to x is the oblique asymptote, but we should also check for vertical asymptotes. Okay, therefore, don't forget, if we are to find the asymptotes, also the vertical asymptotes is x equal to -1, which comes from making the denominator 0. So this is the vertical asymptote. Okay, so maybe we stop here and go on for the minimum point later. And if you have not, you may also prepare this curve sketching worksheet, and then tomorrow we will do some exercises from here. Alright, so and tomorrow, in fact, we will also see how this long division help us with the minimum point as well. Therefore, I find the asymptote first. Alright, so that's it. We go on tomorrow and see you tomorrow. No, not tomorrow. Later in the compulsory lesson. Okay, so goodbye.